So hello everyone. I thought I would like to discuss few more examples or numericals on those kind of links and pairs and joints that we read earlier. In this regard, I choose these two examples. First one will be example which I will be showing you with MATLAB simple program. And then a second one you need to solve yourself. It will be assignment for you. So we'll take this first one as an example. Let's say this is example 1. We have this figure with us having some links and joints. So in this particular example, we can identify the number of links on it. Let me change the color first. Okay, so let's say n is the number of links. So if you consider here, you will see there are in total 8 number of links. Okay, how? Let's say this is link 1, this is a ternary link 2, this is link 4, this one is link 5, link 6, link 7, link 8. Okay, so here you can see there are 8 number of links. Now how many joints? Single degree of freedom joint. Okay, or you can say we can call this as P1 as per our notation. Okay, so how many joints if we consider here? So number of joints are, here you can see, let me change the color to suppose blue here. So this is one joint, 2, 3, here you can see joint 4, 5, here it is 6, 7, then we have 8, then this slider with this fixed surface, so it will be 9, and this one, this slider along with this fixed surface, so we'll have 10. So in total we have 10 joints. Now we'll consider this as a planar case. So for planar case we have our equation to find out the mobility or degrees of freedom. Question is here to find out the mobility for a planar mechanism shown. Okay, here you can see there is no such revolving joint or spherical joint mentioned here, so it is not a case of spatial, it is planar. Okay, so you have to identify like this. So in our planar case, the mobility, or you can say degrees of freedom, f is expressed as 3 into n minus 1 minus 2 p1, or we can say it is, let's say, j1 joint or pair having 1 degrees of freedom. So here we can write 3 into 8 minus 1 minus 2 into 10. So I think 7 is 21 minus 20, so it's degrees of freedom f is equal to 1. Here it is having 1 degrees of freedom. So the same thing we need to find out in our MATLAB. In the MATLAB window you have to define these things n j. So we'll write how I'll show you. N is equal to 8 semicolon then let's say your j1 is equal to 10 semicolon. There is no 2 degree of freedom joint here, so j2 will be 0. Then further you'll write the empirical relation, this empirical relation, okay, this empirical relation, which is equal to, you'll write in this fashion. If you'll define as 3 multiply with n minus 1 minus 2 multiply j1 minus j2. You'll give this input to the MATLAB. Then MATLAB will count its mobility as f is equal to 1. MATLAB will give you this result also. So here it is a simple example, that's why you are feeling that the MATLAB application is not useful, but consider a case of a very complicated example where you need to compare your result with some sort of computer results. In that case you have to take the help of MATLAB. Okay, now we'll straight away go to the MATLAB window. There I will show you how we are calculating. So here you can see the MATLAB window. Suppose we are going to define everything. Our number of links was 8, then say j1 joint with 1 degree of freedom, we calculated it was 10, then j2 you can give input as 0, okay, then semicolon. Now you write down the equation to find out the mobility. Let's say f is equal to, for spatial case, 3 multiply with for multiplication you have to give star symbol into let's say L we have taken here to the number of links, not n, so I am writing here L minus 1, okay, bracket close, minus 2 multiply with j1, okay, minus j2. Now if you calculate, it will give you mobility is equal to 1. You can see here, you can see. So in this way you can calculate any complicated mechanisms, degrees of freedom, using this MATLAB, which is very useful. Okay, I have shown you this simple example. So in this way you can solve any kind of problems. So now I am giving you this assignment, okay, assignment from the first module itself, in addition to those previous assignments, okay. I just want to you to learn this MATLAB program, simple program. So this is one mechanism given to you, okay. Here you can see R, C, S are written. So R stands for revolving joint, and here C stands for your cylindrical joint, and S stands for your spherical joint. So in one of my previous lecture from module 1, I told about these joints and their respective degrees of freedom, okay. So from there, and it is a ternary joint. Here you can see it is a ternary joint. So you need to find the mobility of the mechanism shown and compute the same using MATLAB. Okay, so this is your assignment. Okay, so I need to see it now. One another important aspect I would like to discuss here. We read about kinematic chain. Okay, we read about kinematic chain. What is kinematic chain, then what are the three different categories also we discussed. Now also few other aspects are important, um, like someone if ask you, let's there are three links. Okay, three links connected to each other. Let's say the joints are A, B, C. Here you can see, and the links are, let's say, L1, L2 and L3. Now in this particular case, the number of links, let's say n, or we can say L in some books, okay, it is equal to 3. Now the number of joints here, singly grouped joint is equal to also 3 here, and same as that of a number of pairs. Okay, 3 turning pairs, so L, J and P all are 3 here. Okay, now for deciding whether it is a kinematic chain or not, we follow this simple equation that L is equal to 2P minus 4, equation 1, and equation 2 is also number of joints J is equal to 3 by 2 L minus 2. Okay, so this two equation is to follow. So now for this particular case, if I tell whether it is a kinematic chain or not, so here I can write any mechanism that satisfies the above equations can be termed as a kinematic chain, right? So for this 3 link, we'll see whether it is a kinematic chain or not, because here also you can see the first link is connected with the last one. So here we have, if you consider the first equation, so from equation 1 we can say that is L is equal to 2P minus 4. We have L equal to 3, 2 multiplied 3 by 4. So here what we can see that your LHS is greater than RHS because it is coming around 2. Okay, from equation 2 also you can see which is equal to j to 3 to L minus 2. So we have number of joints equal to 3 by 2 multiplied 3 by 2, which is equal to 2.5. So here also LHS is greater than RHS. So equation 1 and 2 both are not satisfying. So in this particular case, when your LHS is greater than RHS, it is called locked chain. It cannot be termed as a kinematic chain. Now second example, if we take second example, let's say we have 4 links now. Which is a kinematic chain? We know, we have already done this. A, B, C, D. This is link 1, link 2, link 3, link 4. Naming sequence should be followed always. Let's say I'm following counterclockwise. I'm going always from this direction in counterclockwise direction, that you should follow. So here we have number of links L or N is equal to 4. Number of joints, you can see A, B, C, D, so 4. So as number of pair equal to 4. So let us say see now whether it is satisfying both equation 1 and 2. So from equation 1, we have this L is equal to 2p minus 4, so which implies 4 is equal to 2 into 4 minus 4, that is equal to 4. So LHS is equal to RHS here. Now coming to equation 2, we have joint J is equal to 3 by 2 L minus 2. So 4 is equal to 3 by 2 into 4 minus 2. So here we cancel out, it is equal to 4. So here also LHS is equal to RHS. So condition of mechanism when this LHS is equal to RHS, it is called kinematic chain. We have already discussed 3 types of kinematic chains. Okay. Now third criteria, if we see, let's say now we have 5 links, 1, 2, 3, 4 and 5. Joints are A, B, C, D and E. Links are L1, let's say L2, L3, L4 and L5. So here you can see that number of links are 5, number of joints are also 5, number of pairs is also 5. Now from equation 1, we have L is equal to 2p minus 4, so 5 is equal to 2 into 5 minus 4, is equal to 6. So LHS is less than RHS here. Also testing equation 2. So from equation 2 we can say that J is equal to 3 by 2 L minus 2. So we have 5 is equal to 3 by 2 into 5 minus 2, which is equal to, I think, 5.5, right? So here also LHS is less than RHS. So this condition when arises when you can say when LHS is less than RHS, it is called as unconstrained chain. Okay, unconstrained chain. So you remember these three categories. It will be helpful for you. Okay, then this much I would like to tell you. In forthcoming classes will continue.